Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome to this first lecture of Module 8 on rock load and support system. In previous discussions, we have elaborated about the rock bolt and rock bolting, which is one of the support system. Now in these lectures, we will discuss about formation of damage zone during excavation of an underground opening in geoground. In this lecture, we are going to elaborate about rock load or ground pressure, then the factor affecting ground pressure. Regarding this lecture, we are going to elaborate about concept concerned to the rock load, and then concept of in situ stress and deformation, and then formation of damage zone, concept of rock load, definition of rock load and ground pressure, then factors affecting or relevant for estimation of rock load. Friends, the design and behavior of an underground space structure varies from that of other engineering structure developed on ground surface. In case of ground surface structure, the loads are transferred through certain arrangement to the ground or strata or subgrade, and in case of underground structure it is complicated. In case of subsurface engineering structure, the load caused by overburden pressure and due to tectonic stresses, while in case of surface engineering structure, dam, bridge and building, road pavement, highway pavement, etc., the loads are transferred through by the appropriate supplementary engineering structure to the foundation element below the geological ground. Hence, we can say that underground structures are constructed within the geoground with many unknown parameters. However, in case of surface structure, we are having knowledge about the dimension of structure, about behavior of ground through various type of testing, field investigation and field-based testing, etc. Therefore, the rock load estimation, particularly in case of underground structure or underground opening, are very relevant and have vital importance concerned to design of underground structure. Nowadays, we are moving towards the development of underground structure to make the routes shorter, to store hydrocarbons, to dispose some hazardous wastes inside the subsurface, and various underground laboratories, defense chambers. Besides this, classical problems can arise due to variation in rock type from surface toward the depth, then the structural features in rock masses and age of rock formations. Beside this, if we are going to see For example, the older rocks with Precambrian and Paleozoic age can result in huge squeezing pressure. Squeezing pressure is due to deformation of rocks, while the arching effect cannot be found in young sedimentary rocks. And in the design of rock log estimation, the depth of losing zone, the arching effects and the rock support interaction also emerges as important design criteria. Now we are going to see about the factors affecting or factor controlling the rock load, that are relevant parameters utilized for evaluation of a rock load. So first thing, what is rock load? Then we are going to see about different type of approaches and parameters. Rock load is simply weight of rock strata or rock mass. Experience on support system or experience on ground, therefore known as ground pressure. The rock load can be estimated involving important controlling parameters or affecting parameters, namely first in situ stress. In situ stress is playing very important role, that is the initial state of stress in any rock strata or geoground. Another component is structure of rock mass. Previously we have discussed about the concept of rock mass, that is rock block plus joint. So what is the features of joint present in rock mass? Then about the mechanical properties of rock element. Then mechanical properties and spatial distribution of joints present in rock mass, which are responsible for making rock strata, and then mechanical response of support members. The knowledge concerned to the in situ stress, about the structure of the rock mass and about mechanical response of rock element, then about distribution of joints and their mechanical response of support members are going to help in estimating the rock loads. So one by one we are going to elaborate. Initial state of stress or in situ stress, the rock at depth is subjected to stresses resulting from the weight of overlying strata and from locked in stresses of tectonic origin. In situ stress is the subsurface stress. You can see here, this is surface. The stress at a particular point inside the surface is recognized as in situ stress. Stress present subsurface to the earth is recognized as in situ stress. As far engineering geology is concerned, we are going to consider earth crust, because our work is limited to earth crust. Sometimes in exceptions extended up to upper mantle, shallow level of upper mantle. So the rock present over this point is going to make some impact in term of load, that is the weight of overlying strata, as well as the tectonic changes due to underthrusting of plate or due to upwelling of the magma or due to various types of motions along the lithospheric plates are going to result stress. So the overall stress present or total stress present at point A is recognized as in situ stress, and technically we have two components, one is horizontal, another is vertical. In another way we can say that in any strata or any ground, the ground is stable with its own system, own in situ stress. The stress present here is recognized as virgin stress state, or this ground is in under virgin stress state, or far field stress, or simply in situ stress, or initial stress, or stable stress. In such situation, when we are going to create any opening in rock strata or in geoground, the stress field is locally disrupted and a new set of stresses are developed in case of in situ stress distribution. And these new set of stresses are induced in rock strata surrounding the opening. This new set of stresses is a redistribution of stresses try to reach equilibrium condition. In another way we can say that when an underground opening is made in rock strata, the stresses which previously present in rock strata is going to show disequilibrium, require redistribution, and this new stresses which is induced due to creation of underground opening is try to establish re-equilibrium to maintain its original condition. It is the nature of both living and non-living things. If any disturbance in living body also, they try to restore through medical treatment or through yoga or through different type of approaches. Similar in non-living things also, like rocks, rock strata, geoground, when there is any damage in form of creation of opening, then the strata try to restore its original position. Therefore, there is a development of new stress condition, new stress distribution that require as redistribution to reach equilibrium. The knowledge of the magnitude and direction of these in situ previously located in situ stress and induced stress, change stress, is essentially required for design of any underground excavation. So we can say that the knowledge of the magnitude and direction of these in situ and induced stresses is an essential component of underground excavation design. Since in many cases the strength of rock stratum is exceeded and the resulting instability can have serious consequences on the behavior of excavation and ultimately resulting collapse of excavated opening may cause injury to workers working inside or loss of money and delayed in time. Here I try to explain, this is virgin ground where this point A in term of in situ stress in equilibrium. There is no change in condition of in situ stress. The whole strata is in equilibrium, and the rock strata present in this ground is sufficient strong and stable, not showing any type of deformation, damage and others. When we are going to create any underground opening here in any shape, if we are going to excavate this zone, here you can see, excavate this zone, then there is redistribution of stresses nearby this excavated zone. The redistribution of excavation induced stresses try to reach original condition. Due to its habit to regain its original condition, there is a formation of damage zone. You can see, when we are going to create this opening in this type of ground, then there is a formation of one damage zone. This is very simple. If there is impact on your body due to any thrust caused by vehicle or caused by some striking to walls and others, the body is a try to restore its original stress condition. To adjust the original stress condition, if the body is unable to bear, then there is some adjustment type of features. Similar here also, due to adjustment of newly induced stresses to reach its original condition, if the strata is unable to bear this type of adjustment, then there is a development of deformed zone or damage zone. The deformation close to this opening, the intensity of deformation close to this opening is more in comparison to the part lying away from the opening, and finally the effect of this redistribution becomes zero and this original strata in intact form. Therefore, after excavation of any underground opening, there is induced stresses that going to change the in situ stress condition locally. The influence zone is showing the impact of readjustment through redistribution of stresses in form of deformed zone in science, but in engineering, the deformed zone we are going to recognize as damage zone. Therefore, the mass due to damaged this nature which was intact previously or intact here, this mass is going to move downward or here toward the closing, and finally going to create collapse of this created opening. So the movement of this is ultimately resulting collapse of this opening, loss of money, time, and maybe some injuries and damage to instruments, etc. The rock load is very simple. It is the weight of this detached rock mass or detached mass of rock. This material, the weight of this the weight of this weight of this is recognized as rock load. So in simple way, we can recognize simply weight of this detached mass is a rock load. As far as in situ stress is concerned, the in situ stress is going to influence the rock mass present here. This rock mass, rock blocks, whole rock strata, here also you can see rock strata, intact rock strata. This in situ stress present in this type of geoground is going to influence about the attributes of rock strata or rock mass. The in situ stresses affect rock mass property in a number of ways, such as the rock strength or strength of rock strata is a function of sustainability of the in situ stress. If in situ stress are higher and rock is intact, then it means the rock mass or rock strata is strong enough. The stress concentration is inversely proportional to this displacement. If the displacement is increasing, then the in situ stress is decreasing. Or in situ stress is increasing, then not allow for the more displacement. In situ stress normal is inversely proportional to joint aperture. It means the joint apertures is principal parameter in rock mass going to participate in distribution of the in situ stress. Effective stress is also inversely proportional to this pore pressure. Pore pressure is increasing, effective stress is decreasing. Effective stress is increasing, pore pressure is decreasing. Hydrostatic in situ stress tend to close discontinuities or joints. Stress field changes permeability of rock mass, and another way, the stresses cause normal to minimum rock fracturing at peripheral stress direction. High stress causes rock mass to fracture and its quality to deteriorate. The value of Q and RMR we are going to see in reduced manner. Then the rock burst in highly stressed zone we are going to encounter in rock mass and rock strata. Then shape of underground structure is controlled by in situ stress, because we have already discussed in situ stress is going to change the condition as per excavation geometry, depth, etc. The tectonic stresses, erosion, topography and other factors also affect the stress field. In situ stress changes with depth as directly proportional to depth. In situ stress increases with increase in depth. You can see here the in situ stress. As the depth is increasing, it means the lithospheric pressure is increasing or load is increasing, that going to, in general, going to show a linear trend in case of sandstone and others, but in case of shale and other rocks it is slightly different. So as the thickness of the overburden or overlying rock is increasing, then there is increment in sigma lithospheric, and this sigma lithospheric is responsible. This type of in situ stress distribution have horizontal and vertical component, where this in situ stress having this type of notations. Sigma V as a vertical in situ stress. Sigma H is maximum horizontal stress, max, and sigma H min also minimum, because in 3D you can see here horizontal one is a sigma H max, another is a sigma H min, and here is the vertical sigma. In this way we are going to see the distribution of in situ stresses similar to the general stress distribution. The discontinuities or joints control magnitude and direction of in situ stress field. A highly variable in situ stress field exists in the fractured rock mass, because the fractured rock mass without joint concept is having random type, therefore complicated in nature. Next aspect is a structure of rock mass. Before discussing here, I try to briefly explain about the methods we are going to utilize in engineering geology for determination of in situ stress. The major methods we are going to utilize for estimation of in situ stress is flat jack method. Based on flat jack, very simple, two iron plates jointed, welded, have some opening to allow the water or oil or any type of, and this whole system attached with some pump, and we are going to make some slits here, going to put this and going to pressurize. Due to pressure there is expansion in this, and in this way we are going to measure. Time to time we will discuss about this if required. In situ stress, this is the different topic, therefore in brief. Then hydraulic fracturing or hydrofracturing, widely utilized in case of in situ stress measurement and recovery of coal bed methane, shale gas, etc. as additional. Here we have overcoring and undercoring method. Beside this we have many methods, the in situ stress measurement considering Kaiser effect and others. So time to time we will discuss about the content. Here the topic is a different. Another parameter which are going to influence the structure of rock masses, that is the joint. This joint is going to divide the rock mass in certain type of features, and this roughness, filling, aperture, distribution, contact and conditions are going to influence the in situ stress, and in another way rock load. Another is mechanical properties of rock elements. When we are going to compress or tensile this or under shear, the strength and strength related parameters of rocks such as yield stress, mechanical response like modulus, like Poisson's ratio, like failure stress, like residual strength, like peak strength, etc. is going to influence the rock load, and these important components of rock strata, because the block of rock mass is made up of rock. Therefore the strength response or mechanical response of rocks is also very important for this purpose. When we are going to discuss, we have already elaborated This stress strain curve is going to provide about the strength and about the concept of modulus. We are having some ratio of the stress and strain measured in elastic region only. If we are going to determine this modulus ratio by dividing this second modulus at 50% divided by the stress ultimate, then in this way we can divide the rock as high, medium and low. If the value of ES is more than 5, 200 to 500 and the less than 200. Based on the strength also, the rocks can be divided as a very high strength, medium strength, low strength, very low strength. In very high quartzite, diabase, basalt, majority of igneous rock, strong metamorphic rock considered as very high strength rock. However, weakly cemented sandstone, limestone, some hard shell, majority of dolomites, limestone, etc. belongs to high strength. Then shale, porous sandstone, limestone, schistose rock and varieties of metamorphic rocks belonging to medium strength. Then low strength, porous, low density rock, friable stone and very low clay, shale, weathered material, soil, etc. Soil is not rock. So there is also controversy related to the boundary between the rock and soil. If we have time, then we will discuss. Friends, this aspect we have prepared from the book Tunneling in Weak Rock, written by Bhavani Singh and Goyal R.K., published by Elsevier Geoengineering book series and edited by respected Professor John A. Hudson, having page 1 to 489, then partial support by the book Introduction to Rock Mechanics, written by Satyanarayan Bhutkuri and the Katsuyama A in 1994, and the book having page 1 to 272, published in Japan. Friends, in this lecture we are going to conclude the in situ stress present subsurface to the earth, and the excavation in rock strata is causing change in situ stress in localized zone, and a new setup of stresses develop around excavated opening, which are resulting formation of damaged zone and damaged rock and deformed zone. The weight of detached rock mass of damaged zone is called as rock load, and if the rock load is experienced on the ground in form of support, then it is recognized as ground pressure. The rock load is also called as ground pressure. Ground pressure is actually impact of rock load. The ground pressure is depend on the in situ stress, structural feature of rock mass, strength of rock element, characteristic of joints, distribution of joints and strength of joint, then the response of support member. Dear friends, in this class we have elaborated about the concept of in situ stress in brief, rock load and ground pressure, then factor relevant to estimate the rock load. In next class we will learn again about what is the rock load, then in detail about methods for estimation of rock load or ground pressure. Thank you for your patience.